Hello everyone, I welcome you all on this YouTube channel. Hope you all are okay, well and fine. So, this question has been asked in ESE 2007 examination. Please read the question statement. Let us solve this question. What is the frequency of rotor current of a 50 Hz 3-phase induction motor operating at 2% slip? Right? So ABCD, there are the four options. Out of these four options, you know that only one option is correct, right? And that you have to choose that correct option, right? So this is a supply frequency is given to you. It is 50 Hertz, right? What is the frequency of rotor current of 50 Hertz 3-phase induction motor? That means 50 Hertz is the supply frequency. So let me call supply frequency by F1, right? It is 50 Hertz. It is given to you 50 Hertz, right? Now, operating, he has given you the operating slip, that is 2%. So slip of the induction motor, it is represented by a letter S, right? It is equal to, it is given as 2%, right? So slip is 2%. When you remove the percentage, you have to divide it by 100. So this will become 0.02 per unit, right? So this is the slip, and F1 is the applied frequency to stator. Now you have to find out the rotor frequency of rotor current. That means it is F2 you have to find out, right? So I have already explained that the rotor frequency, or you can say the slip formula of slip is, it is given by F2 divided by F1, right? So slip of induction 3-phase induction motor is given by, it is the ratio of rotor frequency F2 divided by applied frequency to stator, that is F1. So from here you can get rotor frequency F2, it is equal to slip times of stator frequency, right? So please watch my earlier videos on 3-phase induction motor. There I have already explained these formulas in great details, right? So F2 is the rotor frequency, it is slip times of applied frequency to stator, that is F1. So SF1 is equal to rotor frequency F2. So now you can find out slip is 0.02 and applied frequency to stator, it is given as 50 Hertz. So this is equal to 1 Hertz. So that is the answer. So which option is correct? Option A is correct, right? So this option A is correct. 1 Hertz is the rotor frequency, right? So you know that the stator winding in case of induction motor is just like a primary winding of transformer, right? And rotor winding is just like a, it is like a secondary winding of a transformer, right? So the operating principle of induction motor and the transformer, both are one and the same, which is mutual induction, right? And the difference is that the flux has to link with the secondary winding in 3-phase induction motor through the air gap, right? There is a stator winding, there is rotor winding, right? In between stator and rotor winding there is air gap, right? So the flux has to link with the rotor winding after crossing this air gap between stator and rotor winding, right? While in case of transformer, you know that in case of transformer, the flux will link with the secondary winding after traveling through this core of iron, right? So this is the difference, and that's why, since the flux has to travel through air gap between the stator and rotor in three-phase induction motor, that's why the magnetizing current in three-phase induction motor is quite high, as in comparison to transformer. So magnetizing, the no load current in case of three-phase induction motor, it is around 40%, right? It is around 40% of the full load current, while the magnetizing current of the transformer is hardly 2 to 6% of the full load current. So this high value of the no load magnetizing current of three-phase induction motor, that is equal to 40%, is due to the presence of this air gap, right? So flux has to travel this air gap to link with this secondary winding, that is a rotor, while flux has to travel to the core of this iron to link with this secondary winding in case of transformer, right? So you know that the air gap reluctance is high in comparison to the reluctance of iron, and that's why you will find the high value of no load magnetizing current in case of three-phase induction motor, which is equal to 40%, right? So three-phase induction motor is a rotating electrical machine and transformer is a static electromagnetic device, right? I have already explained these things in great detail. Please watch earlier videos, right, on this YouTube channel. So that's a difference, right? So since it is a three-phase induction motor is a rotating electrical machine, that's why there will be friction and windage losses, right? But these losses are not present in the transformer because it is a static device. So here in this case, the answer is A, 1 Hertz, that is a rotor frequency. So thank you very much. Thanks for watching. So for all such kind of videos, all such kind of questions, you can subscribe to this channel. You can go to the playlist to watch the videos on the other subjects of electrical and electronics. So lot of thanks. Thank you very much. Thanks for watching.